Pythagoras' theorem. Have you heard of it? Do you know what it's about? Well, Pythagoras is a person's name, a Greek mathematician by the name of Pythagoras, and theorem is basically the theory that he came up with. He discovered a very important theory that we actually apply throughout mathematics, and this theory has got to do with right-angled triangles. What did he find out? He found out a special relationship that exists in all right-angled triangles and their sides. Let's see what he actually found out. Looking at this right-angled triangle, we can see that of course it has three sides and of course it has a right angle, hence right-angled triangle. He found out that the hypotenuse, what is the hypotenuse? It's the longest side in a right-angled triangle. Now this hypotenuse is always opposite the right angle, all the time. The hypotenuse is opposite the right angle. Now this hypotenuse, Pythagoras found out that if you square it, it equals to the other two short sides squared and added together. So in maths, we write it in a formula like this. He found out that the hypotenuse squared, here we marked it as c, so c squared, equals the other two short sides squared added together. We marked the other two short sides with a and b. So the formula is c squared equals a squared plus b squared. He found out that the hypotenuse squared will always equal to the other two short sides squared and added together. This will only work in right-angled triangles. So this is a special relationship that only applies to right-angled triangles. So how can we actually use this in maths? If we have a right-angled triangle and one of the sides is missing, we can actually use this rule and this concept to find the other missing side. Today we're going to see how to find the missing hypotenuse using Pythagoras. Let us look at this example here. We have this right-angled triangle and we notice that the hypotenuse is missing and it's marked with an X. Now the hypotenuse is always opposite the right angle. It is the longest side and here it's marked in black. So we can use Pythagoras' theorem to find the missing hypotenuse. We know it's a right-angled triangle, that means Pythagoras can work. Let's see how we're going to do that. Well, first we write the formula down. The formula states that c squared equals a squared plus b squared. Well, c is our hypotenuse and a and b can be a here, b here, or a here, b here. It doesn't really matter as long as we know a and b are the two short sides and c is always the hypotenuse. Now let's substitute the information to see if we can find x. Okay. C squared, we know it is the hypotenuse, so it's actually x squared. A squared plus b squared are the two short sides. A, we'll put it as 12 squared plus b squared 5 squared. It doesn't really matter a, b or b, a. As long as we know they are the two short sides, a and b are always the two short sides. Hypotenuse squared equals short side squared plus short side squared. Let's see how we can work it out. X squared. Now 12 squared plus 5 squared. 12 squared, 144. And 5 squared is 25. Now we add them together. The hypotenuse squared equals the two short sides squared and added together. 144 plus 25, 169. So x squared is 169. Hang on, we want x. We don't want x squared. So the opposite of x squared, the opposite of squared, is square root. So we square root this side and that side to get rid of the squared. we're left with x, square root of 169, 13. That means the hypotenuse is 13 units long. This is 12, this is 5. The longest side in this case here is 13. So let's go through once again. Pythagoras shows us how to find a missing side in a right-angled triangle. We have this right-angled triangle here and the hypotenuse is missing. We use the formula for Pythagoras. C squared equals a squared plus b squared. C squared is here, a squared, b squared. 12 squared, 5 squared, 144 plus 25. So x squared equals 169 here. We don't want x squared, we only want x. So we square root, and we square root here, x equals to 13. That means the hypotenuse, the missing side in this right angled triangle, is 13 using Pythagoras' theorem. The formula, we substitute, we do our working out. Very important, we square root because we don't want x squared, we only want x. So the opposite of squared is square root. Square root of 169, x is going to be 13. So here, in any right angled triangle, we can find missing sides, and we'll do one more example using Pythagoras to find a missing hypotenuse in another example right now. Okay, we have another right angled triangle. We want to find the missing side. In this case, it's the hypotenuse. Where is the hypotenuse? It's always opposite the right angle. There's the hypotenuse marked with y. Let's use Pythagoras' theorem to find the missing side in here. It's the hypotenuse. The formula, c squared equals a squared plus b squared. We know c is always the hypotenuse. The hypotenuse is there, it's the y. A squared and b squared, it can be 4 squared and 3 squared. So 4 squared plus 3 squared. Keep going. 4 squared is 16. And 3 squared is 9. Y squared is 25. 16 plus 9 is 25. We want to work out y, not y squared. So what do? The opposite of square, very important, we don't forget, is square root. When you square root y squared, the squared goes, you're left with y. Square root 25, in other words, what number multiplies itself to get 25? Our answer is 5. That means the hypotenuse is 5 units long. This is a right angle triangle. We used Pythagoras' theorem to find the missing hypotenuse. C squared equals a squared plus b squared, meaning the hypotenuse squared equals to the short side squared plus the other short side squared. We did it here, 4 squared plus 3 squared, 16 plus 9, square root 25, y equals to 5. The hypotenuse is 5. How do we know, or we have a rough idea whether we are right or not? Well, we know that this is 5, and we know the hypotenuse is the longest side. So 5 is longer than 3 and 4. So that gives us a good idea that yes, we are on the right track. We got it correct. And of course, when you follow this, you'll always get it right anyway.